It's coasting to a stop. What do we use for a vehicle in here? What was it? Oh, a hovercraft, yeah. So we got a hovercraft coasting to a stop. How far have we traveled? In order to find that out, we need to find the area under the curve, because we're graphing velocity versus time. So area under the curve would be the distance or position. How could we do it? We have 4 ways. Give me one. Jake. I'll combine all of them into rams. So write ram down. That's one way we can find the total distance given a velocity versus time curve. Simpson's rule. Very good. Trapezoidal rule.
Profession integration.
How could we integrate this?
Ram.
Yes, we would have to do a regression to get the functions equation, and then we would integrate that. So that is another option. Okay, so RAM, trapezoidal, Simpsons, and regression/integration. Is this an example of a regressionable function? Look it up, I'm sure it's not a word.
The one on the bottom or the one on the top?
The one on the top. Does it seem like you could identify what type of a function it would be?
Yeah.
What would you identify it as?
Exponential.
Exponential decay, right? It's pretty obvious that it's decreasing at the same percent every time, so yes, I would say that's exponential decay. Therefore, you could do a pretty accurate regression and then integrate it, and you get a pretty good feeling of how far it's actually traveling. Okay, looking at the bottom one. Traffic light. So, I went out Saturday, and I sat at a traffic light all day long from 5 a.m. to 7 p.m. So sorry, not all day long. So just 14 hours. And I accumulated a whole bunch of data.
You're a great calculus teacher.
It's a good Friday night.
And that determined, yeah, I'm dedicated.
Or is that what student teachers are
I should have had him.
I recorded it.
Yeah, you recorded.
That's my job. Okay, so here's what I came up with. At 8 a.m., there were 16 triggers. Look at that. High traffic in the morning. Rush hour. A number of people went out over lunch and then rush hour to the evening. So, again, we could use those 4 techniques. Do you think that, what type of an equation do you think that would be? Okay, you said sine. Sinusoidal means it's periodic. It repeats itself. So every day, at least Monday through Friday, it should be close to what it would get. Okay, weekends might change, but if we're only talking week, I took the data on a Saturday, supposedly. If I said it was yesterday, you would have said, no, you were here at school. I said Saturday. So this is Saturdays. We'll do it every Saturday. Okay, so sine, do you think a sine regression would give you a good, accurate model?
Some of it maybe.
Yeah, so for parts of it, but I don't think it would be very accurate. What else could it be? How many different times does it change directions if we were going to represent using a polynomial?
Would you be
1, 2, 3, 4, 5, 6. So we could represent this with a 6th degree polynomial. How accurate is this going to be? Let's not.
more
Yeah.
accurate, but not exact?
Okay, so my point is regression, integration. Any way you look at it, it's probably not going to be all that accurate. So we would have to use RAM, trapezoidal, or Simpsons. So there is a place where you would need to use those approximation techniques.
Is Simpsons going to be most accurate in most cases?
Yep. All right, so we've already gone through halfway down the next page. I already asked those other questions. All right, so below this, where you've got some space, do a squiggly vertical line right in the middle of your page. Choose one of the 2 sides to answer the question. That's your velocity. If S of 0 equals 9, find I'll give you a few minutes to figure that out. Solve the problem.